This is another example of a central limit theorem. So we have ATM machines, they are full of cash, and employees put cash in the ATM machines on the weekend. So it's Friday, Saturday, and Sunday, and the people take out cash from it, and what they want to know if there is a remaining cash on Sunday evening, or whether or not the cash is going to last the whole weekend. How do you know? So the question becomes, if you put a certain amount of cash in the ATM, what is the probability that it will last the entire weekend? Okay, so we're gonna consider each withdrawal as a random variable. Someone might be withdrawing 500, someone might be withdrawing 500, so it's going to have some sort of distribution. Banks can look at the withdrawal data, and based on mean and expected variation, you can derive that. So all the withdrawals from the ATMs are going to be IID, and suppose in a particular weekend there are 400 withdrawals. Total withdrawals, you can sum it up, and x1 plus x2 plus x3 all the way to xn, and expected value of xi, let's just say, is 3,000 rupees, and the standard deviation of x is 750 rupees, and this is from historical records. There are and the n is 400. Suppose in the beginning of the weekend, bank put in 12 lakh rupees in the ATM, and we want to calculate the probability of S being less than, because if the probability of S, or all the sum of all the withdrawals, is less than, then it's going to last. So what is the estimated value of S, which is going to be the sum of it? There are 400 times 3000, that is 12. So you would say, okay, well, 400 withdrawals and 3000 rupees is the expected value of each withdrawal, and that's why we put 12 lakhs in it. But then there is a standard deviation also of S, which is going to be what? Now there are, so the variance, we're gonna, so here it's going to be under root n times the standard deviation, and why under root n and not n is the question. So variance is the what you sum up. Variance is n times variance, so that's going to be 400 times 750 square. So what is going to be the standard deviation? This is going to be 20, which is under root n, times 750. So that is why this is 20 times 750 and not 40, and that's going to be 1500, 15,000. So ATM has 12 lakhs, which is the same as the expected S of the mean, or the mean value, if the total value is going to be more than the mean value. So probability we're gonna do of S minus 12,000 or 12 lakhs divided by 15, which is the standard deviation, is less than 0, because if it is less than 0, that means that this S is less than the mean value. So if you just put 12 lakhs, then it's going to be probability of 0 less than 0, which is going to be 50%. But say if we put 13 lakhs, so if we put 13 here and this comes out to be 12, then this is 6, and now you find that the probability is going to be close to 100%. So what expected value of x is, what it is the mean, is the mu, right? And this is the standard deviation, and what we want to know is this value x. So this is just calculating the z-score of this, which is x minus mu upon sigma. We want to know what x is going to be. Now if x is going to, if we just put the x as 12 lakhs here, then it's just going to be 12 lakhs minus 12 lakhs upon 15,000, and the z-score of that is going to be 0. So if we want to calculate the area, which is here, of 0, so that is going to be 50%. The probability of this value to be, of the probability of this area to the right is going to be very high. 50% chances that this is going to be less than the mean value. But if we put 13 lakhs, then it is 1 lakhs here, and then it comes out to be 6. And when you put 6 into this, then the 6 is going to lie like over here, very far over, and this basically this comes out to be 0. So the probability of this z-score to be higher than this is almost 0. And if, say example, you put 1, it's going to be here, which is still come to be like 15.87%. It's going to be less, and if you put but you don't want it to be minus 1, because then it's going to be very high. So for example, if you put the value of this as minus 1, then the area is going to be 84%. Then there is 84%, still not 100%. So even though you are putting less than the mean value, the area to the left of this is going to be 84%. So that is how you can calculate the